So today we'll talk about how to implement the DI method properly. We will use a method which is called the Liate method. Liate as in L-I-A-T-E. L stands for log, I stands for inverse, and the A stands for algebraic, and T stands for trigonometry, and E stands for exponentials. Now let's say that we have a function to integrate. Let's say we have a function like this, which is x squared and ln x. Now when we use the DI method, as usual, we will get two columns, and which function, there are two functions in this part, which is x squared and ln x. Now which function to differentiate and which function to integrate. Now which function to differentiate, we will use the Liate method, which is log is the first one to differentiate. So if you can see that there's a log in this function, so we will use that to differentiate, and to integrate we will integrate x squared, and as usual add plus and minuses in that. So it's 1 over x and x cube over 3. Now we know that this can continue forever, so we can just stop right here, and the integration of x squared ln x, it will be to cross multiply as usual, which is ln x multiplied by x cube over 3 minus multiply these two and integrate the end result. So it's actually plus, not minus, because as you can see that there's a minus over this point. So it's minus 1 over x and x cube over 3 dx. So the value will look something like this: x squared over 3 and dx. So that's the final answer. Now, when can we not use the Liate method? Let's say we have a function which looks like this, and we're told to integrate this function. So the integration of sec cube x dx. Now, can we write this expression in this format? It's basic indices. Now if we use the DI method in this case, so it will look something like this: d and I. Now it's impossible to integrate sec cube x, so we can break it down in this format. Now we get these two different functions, which is sec x and sec square x. Now we cannot use the Liate method in this case because both functions are trigonometric functions. So now ask yourself that which one is easier to integrate. Now in this case there are two columns, which is d and I. Normally we choose which to differentiate first, but in this case it's a bit different. In this case we'll choose, because integrating a function is way difficult than differentiating. Now if you look at sec x, is sec x possible to integrate? Yes, it's possible, but is it worth it? Because integrating sec x will take more effort than usual. But now integrating sec square x, is it possible to integrate? Yes. Is it easier to integrate this? Yes. So you will integrate the sec square x and differentiate the sec x function and add the plus and minuses as usual. So differentiating sec x will give us sec x and tan x, and integrating that will give us tan x. Now we cannot differentiate this much further, so we can stop right here. So the integral of sec cube x dx is cross multiply as usual, which is sec x and tan x, plus multiply these two and integrate the product. So multiplying this will give us minus sec x and tan square x, so the final answer will look like this. Now we have to integrate this. So in order to integrate this, it's possible to integrate this alone, but it's very difficult, so it's not worth it. But what you can do is that we can use a trigonometric identity, which is we can write tan square x in the format sec square x and -1 dx. Now we can write this as minus integral sec cube x dx plus integration of sec x dx. Now as you can see, there are two identical variables in this equation, so we can just bring this over to the left hand side of the equation, and then we will get a value of this. And the integral of sec x is actually ln modulus sec x plus tan x. And now just divide the whole equation by 2 and you will get the final answer, which is sec x and tan x over 2 plus ln sec x plus tan x modulus over 2, and you have to add a plus c at the end. So this is your final answer. So I hope the DI method is clear to you all now. So you can use the Liattay method. Usually we use the Liattay method, but when it comes to functions like this, we have to use this method. So it's not a different method, it's actually the steps to this method is that you have to identify the function to integrate first, and then pick the second function to differentiate. So I hope this is clear to you all, and thanks for watching.